we're going to do some of the exact same problems that we did last year in pre-calculus, only we're going to get to more difficult problems, trust me. But now we're going to do them from a standpoint, from a perspective of differential calculus. And we can make them considerably easier. Now, I'm going to move through these pretty quickly because you've seen them before. The ones that you haven't seen before, we will slow down. So, farmer is going to make a rectangular pen out of 480 yards of fence. He's going to divide that pen into 3 sections. All are equal size. What should the dimensions be to maximize the area? Now, this is a difficult question. You guys know I like the 4-box approach when I solve word problems. 4-box approach. There you go. That's all right. Okay. Yep. All right. We're already confused. All right. So I'm going to have width. I'm going to have width, width, and width, and length, and length. Now, what I want to identify is what my overall objective is. What is the overall objective of this problem? Maximize area, okay? And this is what's going to drive the problem. So I have to write an equation for area, namely that area is equal to length times width. So I want to write a function for area, but I can't use 2 variables. I need 1. So help me out. 4W. What's 2L? 480. Good. Now I have 2 equations, so I can solve for a variable. So get it in terms of W. That way I can substitute back in. 2L equals 480 minus 4W. So L is 240 minus 2W. Take that, plug it in right there. Is everybody okay with that step? Now, what? No. I solved for L in terms of W. So right now, area is in terms of what variable? W. W is the variable that will be used. So A of W will be equal to 240 minus 2W times W. We distribute that through. Area in terms of W is equal to 240W minus 2W squared. That's my function. If I am going to maximize the area, right, I want to find the maximum location of that graph. The absolute max, in this situation, it is the absolute max because it's a parabola. But generally speaking, these happen at local maxes. Okay? So as you look at this piece right here, what graph does that make? What shape? Upside down parabola. Does that have a maximum? It sure does. And so that maximum has a very special relationship with the derivative. Namely, that the derivative of a function at the maximum is going to be equal to 0. So 0 equals, what's the derivative? 240 minus 4W. So I get 4W, 40. W is 60. Last year we talked about parabolas and we did negative b divided by 2a to find the vertex. Well, that limited us to only parabolas. Then we had to ask about, well, what do you do with cubics and everything else? You could only use calculators. Now what I have here is I can use differential calculus. Yep. I'm sorry, I should label this a little bit better. The width is equal to 60 yards, and the length is equal to what? Plug 60 into where? 240 minus 2W. 240 minus 2 times 60? 120. So 60 yards and 120 yards. Okay with that? All right, so yes, these problems did take us a while before, and that's why we revisit them so that they go quickly. You just straighten your hair out or what? Okay, yep. Yeah, very good. So, well, so let's say you have something like that. The question is, okay, let me just give you a scenario here. Suppose that one was 60, and this one was 600. Which one would you choose? In this problem, You would choose 60. You couldn't, no, watch. You couldn't choose 600 because do you even have 600 feet of fencing? No. So generally the problem will have solutions that need to match with the certain domains. Okay. All right. Does that make sense? So, whoop. All right. Yards. So, all right. Farmer builds a rectangular fence up against a barn. Thus, he doesn't need any fencing against the barn. This is our barn. I've used that line with my children. You think we live in a barn? You should pick up your clothes. Come on. I'm a terrible father. Thank you. You're a terrible student. What? Well, I've just heard it many times. Heard it from my parents, my grandfather in particular. Okay, width and length. You said, why is the fence so small against the barn? We don't know. We're maximizing the area. You say small. Small is very relative to. Maybe the barn is a couple. Yeah. A 5 mile long. Jeez. Okay. Sam laughs a lot. He does. He does. I get to see it because I'm teaching class. Okay. All right. So formulas. Give me some. Let's go. What else? Katie's on a roll. So area is equal to L times W. L is 320 minus 2W. I can now write a function in terms of area, or for area, in terms of what variable? W. Amber A for the day. We get length is 320 minus 2W. We'll multiply that by W. We get 320W minus 2W squared. That is the function of area. You tell me, what shape does this make? Parabola, it's upside down. And furthermore, can you take the derivative? You get 320 minus 4W is equal to 0, because that's where it has a maximum, is where the derivative is equal to 0. You get W is 80. So we have W is 80 feet. And as Katie said, the length will be 160 feet. And that's our relationship. Anybody questions on that before we push forward? Well, you know, maybe you got chicken. Cassie, I have to ask your opinion on this conversation. What do you think? Is this Cassie speaks? She says it's stupid. I agree. Let's move on. Oh. Okay, here we go. We have a rectangular piece of cardboard. Measures 10 by 18. And yeah, what we're gonna do is we're gonna cut corners on it, and we're gonna then fold up the sides to make a box that has an open top. Okay, so these dotted areas will be discarded. What we're going to do is we're going to fold along the red lines here, and we'll flip those up, flip the side up, okay? Flip the side up, flip the side up. Ooh, very well played. Good point. We will not cut the corners. We will saw them. We'll saw corners. So, now, you tell me where to go, what to do. If you remember, there's a 2x involved. Very good. What is the entire dimension, folks? 18 and 10. So that's something to keep in mind. Now, furthermore, what is our objective? Largest volume. So you must always go to the objective and derive a function from there. So our volume is equal to what? What is the... Thank you. Does everybody understand why it's 18 minus 2x? Because I'm going to saw off these corners. So I will have 18 minus that x is minus 2x. So the width won't be 10. It will be 10 minus x, which is minus 2x. What about the height? X. When I fold up this side, it will be the height of whatever I've cut. Can I do the derivative of that? Could I take the derivative of that? I could, but it would require the product rule twice. We could just distribute the x, product rule once, or we just multiply it out. Let's multiply it out. Volume in terms of x is 18 times 10 times x is 180x. 18 times negative 2 and negative 2 times 10. Negative 36 and negative 20 makes negative 56, and I will have an x squared. Negative 2x times negative 2x, 4x squared, and then times x is 4x to the third. There we have it. Take the derivative of that. But first, what shape does that make? A cubic? So when I take the derivative, how many places will I solve equal to 0? 2. Which one will it be, the first one or the second one? The maximum one, not the minimum. Now, also just understand from the context of the problem, I'm getting an x value. What is the largest x could be? What's the largest square I could cut off? 5. 5 would be the largest, because if you cut off 5 from this side and 5 from that side, that would be all of the 10. You would have nothing left to fold up. Okay? So, 5 is the largest value. Everything has to be less than 5, between 0 and 5, so we know that. So, let's take the derivative. V prime of x, set it equals 0. What's v prime of x? Why don't you go ahead and type that in on your calculator using the quadratic formula. X equals what? And 7.27. Okay, so we just talked about the domain of this problem. You can't have a value bigger than 5. So obviously you don't want to cut 7, do you? 7 would refer to the minimum volume. That would give you a negative volume if you were to cut that much. It just seems ridiculous, but in context of the problem, that's what it is. So 2.06. So does that answer the question for you? What is the what? Into what? Volume. The question is largest volume. What is the largest volume? So you need to take V of 2.06. When you plug in 2.06 into that, no. If you plug in the derivative, you're going to get, if we plug in the derivative, what would we get? 0. We need to, this tells us volume. The question is, what is the volume? And we are in inches. What do you think? Yeah, I mean, you do appreciate that taking the derivative and saying something equals 0, that's... Well, you didn't know calculus, though. I mean, we had to look at the calculator and use the max min function on our calculators. Okay, we'll venture forward when we get back from break. No, you would have to walk in. Yeah. Okay, suppose that I'm not helping you and that you guys have to do this problem on your own. Let's look at problem 4. If I wasn't here to help you, you had to do it on your own, what would you do? Tell me what you would do. I'd do something first. Okay? Then what? Then draw 12 minus 3x squared. What is 12 minus 3x squared? It's a parabola shifted up 12 units, and it goes down. Does anybody tell what the x-intercepts are for that? 2 and negative 2. Luke Sunblad, A for the day. You know, you didn't have to go there, okay? Please. So, what we want to do is sketch a rectangle whose base is along the x-axis and whose corners are on the y-axis. And we want to draw the rectangle that has the largest possible area. Suppose you drew a rectangle that went all the way up to 12. What would its area be? 0. It would have 0 width. Suppose you drew a rectangle that went all the way out to positive negative 2. 0 as well. So you do have, you know, this maximum amount that sits somewhere between in those values. So what are you going to do? This is your problem, not mine. What do we got to do? Area, thank you. Tell me more. Very good. Amber's right that the base does have a length less than 4. I need variable because it changes. 2x. Yes. Very good. Bo is correct. The area, the length on the bottom will be 2x because you will have x in each direction. That will be the length of the base. However, the height or the width will be the same as the y value. And the y value, Katie was kind of going towards this as well, the y value is the same as 12 minus 3x squared. So now I have what I need to be able to write an equation. My area is in terms of x. It's equal to 24x minus 6x to the third. Note that I know it's x on both sides because this is a symmetrical graph. X to the second and x to the 0, that's an even function. Even functions are symmetrical about the y-axis. If you notice, this is an odd function. Odd functions are symmetrical about the origin. So if we were to graph this, because it's negative, it starts up and ends down as a cubic. And as it's odd, it's going to look something of that nature. So as I solve for x for the derivative equal to 0, how many results will I get? I'll get 2. Simply one that creates the positive x value and one that creates the negative. We don't worry about the negative one because we're talking about distance here. So we want the positive value. What is the derivative? Yes. 24 is 18x squared. Divide both sides by 20 or 18, I get 4/3. So 2 over the root of 3, which is 2 roots of 3 over 3. Everybody okay with that? What did I just find? Found x. What does x represent? Distance from 0, and I want the entire length. What's the length going to be? Double that. So 4 roots of 3 over 3. And if I want to know the width, plug it in where? No. Okay, we know that y is equal to 12 minus 3x squared. That gives us our width, our y value. So we're going to take it and plug it in there. Not for area. If we plug in area, we will get the area. So we have 12 minus 3 times. If I square this, do you see how I'll get 4/3? Remember when we took the square root, we got that. So if we square it, we get 4/3. 12 minus 4 is 8. What do you think? You don't like it? Yes, I definitely have order. No. Okay. Last problem for the day, and then tomorrow we'll move on to more difficult problems. Okay. I have an assignment for you that you can either start working on today or tomorrow, but you do need to keep up with your calculus right now. You will fall behind if you don't. So. All right, last one. Rectangle is inscribed in a semicircle of radius 16. What should the dimensions of the rectangle be in order to maximize the area of the rectangle? A little bit different problem here. Tomorrow, we're going to try problems that are very unique. All of these are generally rectangle, cube type shapes. You know, we're finding volume, area. It's going to be a little bit different on the next few, okay? So these are just really review type problems we set up. We've done this one before. We did it last year. You tell me, where do I start by setting it up? Okay, so I will draw it on a coordinate plane. We always like to go to the coordinate plane. It makes life easier. The coordinate plane really wasn't developed till 1600s. Descartes put it together for us. Well, next to Cassini bar. Everybody okay with that shape? And now we are going to put a rectangle right smack in the middle of it. Somebody help me out. Okay. Kind of like I did the last one, so tell me what to do. All right. Now what? Very good. 2xy. Now, Marcus is trying to figure out what y is. That's what he's doing right now. You guys tell me. Oh, so what you are doing right now is, okay, x squared over 4 plus y squared over 4 is equal to 1. So he's remembering from ellipses last year that um, it stretched 16 units, so he chose 4, but it would actually be 256 would be on the bottom, is what we choose. Okay, so he's trying to work through that. This is just the equation for a circle. And you guys know the equation for a circle because that's the equation for the area of a circle. We want the actual coordinate equation for a circle. X squared plus y squared is equal to the radius squared. Katie is almost correct. Now, you may say, how are we supposed to remember that? It is the Pythagorean theorem. You can remember that. Okay. All right. So, what is our radius? Therefore, the equation is x squared plus y squared is equal to 256. So, Marcus was on the right track as well, only you needed to divide by 256, not by 4. And then you could have multiplied through by 256 and we got the same equation. So, and we are doing conic sections right now within pre-calculus. So this is learning we want to try to work back through. And now we need to solve for what? Y. So we have y squared is equal to 256 minus x squared. Now what? Square root. And when you square root, you get a positive and a negative. But since it's the top of the semicircle and not the bottom half semicircle, we just need the top, which is positive square root of 256 minus x squared. Can I square root the 256 and the x squared? Nope. Cut your head off. Area in terms of what variable? Equals 2x times square root of 256 minus x squared. I know what that graph looks like because I've seen it before. It looks something like this. Don't draw this. That's what it looks like. Okay. But what we need to do is find the derivative and set it equal to 0. I'm going to start here because this is going to take some space. In order to find this derivative, what do I have to do? Product rule along with the chain rule. A prime of x is equal to, what is the derivative of 2x? 2 times the square root of 256 minus x squared plus 2x times, now I need the derivative of the square root of 256 minus x squared. Chain rule, u to the 1/2, 256 minus x squared. What's the derivative of u to the 1/2? 1 over 2 roots of u, thank you. And derivative of 256 minus x squared? Negative 2x. I multiply, I get a negative x on top. Negative x over 256 minus x squared. I'm going to take that and set that equal to 0. So 0 equals 2 roots of 256 minus x squared minus 2x squared over square root of 256 minus x squared. You could either add over the negative portion and cross multiply, or you could just simply find common denominators. Doesn't matter. Second, I already found common denominators. Ask one question. Yep. Just find a common denominator, multiply by the square root. It works out very nicely. Very good. Done with. Multiply top by square root of 256 minus x squared, and that square root will go away, correct? You get 2 times 256 minus x squared minus 2x squared all over the square root of 256 minus x squared, which is 2 times 256, 512. And then negative 2x squared and negative 2x squared, you get 4x squared over the root of 256 minus x squared. This made some people angry during the second hour. Do I need to focus on the bottom at all? No, it's the top that will make it equal to 0. So just disregard the bottom. Just look at the top. If you set the top equal to 0, you get 4x squared is equal to 512. Divide both sides by 4, and we get x squared is equal to 128. Square root, and x is equal to square root of 128. Your perfect square you can take out would be 64. You get 8 roots of 2. When you simplify that, what have we solved? Right, we got to double that because the width is 2 times x. Or, I'm sorry, we called that our length. So our length is 2 times x, or 16 roots of 2. The width would be... Katie's on fire. She takes 8 roots of 2, which is our x value, and plugs it into here to find our y value. If you notice, obviously if you square 8 roots of 2, what do you get? 128, and 256 minus 128 is 128. Square root of 128 is 8 plus 2. Bada bing, bada. I wouldn't say that this is easy. I would say that this is, what's nice is that this sets up in accordance with a lot of the other problems we've done. This is without a doubt the most challenging problem that we've done today. However, what I would like from you guys is please turn the very last page of the notes I gave to you and rip that sheet off. It is a, yep, you're going to have a couple assignments from this unit. This is the easier of the 2 assignments. The problems are going to be very, very similar to what you've seen in the problems that we've done in class. Okay. Yes. So your assignments from this unit so far are 4-3, 4-5, which was the large curve sketching one, and now this. Okay. I want you to know that I know we're covering some big and challenging topics, but overall this test has gone very well for people. Very well. I believe in you guys.